All right, our videographer is absent today. Who would know? How do we cope with such a situation? All right, Emily, sorry you're not with us. I heard you're not feeling well, so please know that we're thinking of you and miss you and hope you get back soon.
We're also really disappointed in you.
That's not true. So, all right. We're looking at the on your own problems that we had to bring with us today, and I believe it looked like this one. So find that one that we were working at our tables when the class ended. Do you have yours out? Brian, could you read the scenario here, see if I've got the right numbers going?
The car has a maximum acceleration of 1.15 times 10 to the 4th miles per hour squared. Or, it's gone like, 11,500 miles per hour squared. If it starts from rest and accelerates as quickly as possible for 500 yards or 5.00 times 10 to the second yards, what will its velocity be?
Okay, I did have the skeleton of that up there, so hopefully you have that. Do you need that paper, Brandon? Can you find it? There you have it.
So, which one?
It is the on your own problem, so it should be the last one. Here we are. We're talking about this one. All right. No, we're talking about this one, on your own. We talked about that one earlier. This one and then this one were assigned last night. So here, if you could kind of do that while we're doing it, you'll be all caught up. All right. So, Brian. Here's the big five, and I'm trying to figure out what equation to use. So would you tell me do we know velocity initial in this problem?
Velocity initial?
Yes.
Initial velocity is 0.
Right, so we know it.
Starts at rest.
Okay, so do we know the final velocity?
No.
But we have to have it in the equation because the question asks for it. So I'll circle it. That means it's got to be there, but not necessarily know it at the beginning. Do we know the acceleration?
1.15 times 10 to the 4th miles per hour.
Do we know anything about time?
No.
Okay, time is a no-show. And what about distance?
Yes.
Yeah, 500 yards, you mentioned. So I give that a check. So putting that all together, which of our big three equations has to come out to play for this one? This is probably the biggest clue. There's no time in it. So which one, Brian?
The middle equation.
Right, the middle one. So did you pick this one? All right. All right, any questions on why we picked that one? All right, putting the numbers in the correct place. I had to change 500 yards to miles, so if you forgot that, your answer will be a little off, and you'll have to go back and switch it. 500 yards times, they gave us, when they give you that data in the problem, you're probably going to need it, so that was a clue. So it was 0.284 miles when I did that, and putting in, the final velocity was 0. Initial velocity, the final velocity is what we're looking for. The initial velocity is 0. The acceleration, I'm going to just move my decimal over, 11500, and that is 2 times that, and x was 500 yards. I can go back there and grab sig figs. So when I put that all in, I got a number, and I took the square root of it.
Well, you can convert it yards to miles, right?
Oh yeah, did I not grab that number?
Sorry, 0.284.
0.284, thank you. 0.284. All right, I think I did do it that way the first time. All right, so when I got this number, it came out to be 6,532, and I ran out of board space, but the final velocity was the square root of that number. 6,532 square rooted came out to be 80.8. All right, were you able to get 80.8 on that one? All right, you could be writing that in right here. What about you? Did your 80.8? How about you, Zach? Did that come out? Yes?
No.
Okay, did you have a mistake earlier?
Yeah.
Okay, what was it?
Guess you can put a fan.
Converting
Thank you.
the miles.
Okay, all right, so here's where I converted, and here is the end of the problem. So, All right, questions. Let's go look at the second on your own. And here we need a reader. So Emily Martin, 2.3 on your own. It's on the bottom. Here, Brandon, we're on to this one now. Okay.
A race car starts at rest and travels 1,321 feet, a quarter of a mile, in 11 seconds. What was the car's acceleration?
Okay, so if you would, Emily, help me with the same list of variables. I always start here and erase what was here from the previous problem. Do we know initial velocity? Do we know final velocity? Do we know acceleration?
No.
But we need to have it in the equation because that's what we're looking for. So I circle it. And do we know time?
Yeah.
Do we know distance? All right, so which equation will help us with that? The third one. Notice the other two have velocity in final, and we don't know that. So we can't use the yellow or the green. We're down to the red equation. My most excellent advice to you is the vote and have at it. All right, so putting in the numbers appropriately. This zeroes out, so I won't even put in the time. 1/2 acceleration is what I'm looking for, and time is 11 squared. So I took 11 and squared it, took half of that, and divided 1321 by it. So when I did that, I finally got an acceleration of 22. Anyone agree? Confirm? Yes? Okay. So I could show you the math in between, but let me do that at your seat. If you don't know how I got from here to here, I will show you that during our work time, which is coming up. How many minutes are we at now?
We're good. We're at
7
minutes.
Just 7?
Yeah.
Okay. All right. That was last night. Today we're not going to have any new information other than these 3 equations. So what I'm going to set you to do is several things. First of all, what's going to happen, I don't know if you noticed, I think I pointed it out yesterday, I taught an equation, we did a problem using that equation. Then I taught another equation and the next one matched and so forth. Now they're going to be all mixed up. So the problem that we're going to do 2 examples, and then I'm going to give you like 8 problems to do. But each person is going to be in charge of 1 problem. So you're going to start with 1 problem. You're going to get it. It's going to be unlike all the other problems in the class. So you have your own problem, and you're going to be very attached to it. So you're going to take your own problem that I give you, and you're going to write it up on a little card, or not a card, I guess it's not quite a poster, but a large card. And that will serve as a guide to those in the rest of the class who eventually will have to do your problem. So you're going to be able to help them. So more on that later. So we have to train on how to get these done. So I'm going to give you your day 2 sheet. So if you would show Emily this sheet when you get yours, just shine a light on it so she can follow the problems.
Okay.
And she can just pause. Oops. Sorry there. Alex, do you mind grabbing that? It fell on the floor.
That's fine.
It's no new information, it's just more practice problems today. So, let's look together. We'll talk together about 2 more. And why don't you, after you show that, just shut down the video and start it again. And it should be all I need to do as far as this class. All right, going around, Zach, we're over to you. So would you read the first problem?